Okay, so we're going to graph the ones where we have to shift them today for 7.3 part 2, and then we're going to talk about a continuously compounded interest problem. Because we've done compounded interest, but we haven't done continuously compounded. Okay, there's a difference. Compound interest means that you're getting interest quarterly, monthly, whatever. Continuously compounded interest is that you get interest off of the interest you also made. So you're continuously getting interest. Hence the term, continuous compound interest. I'm going to switch the markers on these so that we can see them in different colors. Okay? And then I'll shift them with the final color. You have to have a calculator for this. I cannot do this without a calculator because there is a natural log and there an E, okay? So basically, we're going to start off the same way. When we dealt with graphs before, we just graphed the part that was like this, right? And then we went back and shifted it. We're going to do the same thing. We're going to go back and shift it after we plug in numbers for that portion, okay? So I'm going to say X, Y. Let's do, what numbers do we want to do? First of all, which way is this graph going to fall with that negative 0.75? Is it going this way or this way?
This way.
Yeah, it's going this way. Okay, so I already know because of that negative 0.75, it's going to shift that way. So I'm going to plug in numbers. Let's just plug in -2, -1, 0, 1, and 2. Like I said, we always keep it simple in here, okay? So if I plug in a -2 to this, okay, what happens? I get e to the negative 0.75 times -2, right? So you should get something like 4.5 out, I believe. Double check to make sure that you're doing it like I'm doing it. I always need to be checked, you know what I'm saying?
What'd you get?
I got 4.48, I rounded it to 4.5.
Yes, I got.
Okay, beautiful. Now if I plug in a -1 to this equation, once again I'm doing e to the negative 0.75 to the times -1, and you should get 2.1. Anything to the 0 power is what? 1. So I have e, well, I have e to the 0 power, right? What if I put 0 in there and 0 times that, which is 0. So I get 1. Plug in 1 and I get e to the negative 0.75. I don't need to do, oh, come on, I'm being silly right now, I can't type. I don't need to multiply this by 1 because it's just negative 0.75. And you get 0.5. And then I'm going to plug in e to the negative 0.75 times 2, and you get 0.22, okay? Which makes sense because you told me my graph should go this way, and that's what's happening. So if I go to -2 and I go to 4.5, 1, 2, 3, 4 and a half. And if I go to -1 and I go to 1, 2.1. And if I go to, I need to make these dots big so that we can shift them. If I go to 0, 1, and I go to 1 and I go to a half, and I go to 2 and I go to 0.22. Is this graph going the way we want it to go?
Yes.
Yes. Now we have to go back and shift these points, correct?
Well, yeah.
Okay, we have a -2 right here and we have a +1 right there, correct? So if it's -2, that means I am going to the right 2 and I'm going up 1, yes? Right 2, up 1. What's wrong, Cole?
He didn't get the first one.
I got it. Okay. So I'm going to add 2 to all of these points, yes?
Yeah.
And I'm going to add 1 to all of these points, yeah? When I add to here, I get 0 and I get 5.5, right?
Yes.
When I add here, I get 1 and I get 3.1. When I add here, I get 2, 2. Here I get 3, 1.5. And here I get 4, 1.22, yeah? Okay? So I'm going to shift all of those points over to the right 2 and up 1. So I go to 0 and I go to 5.5. 1, 2, 3, 4, 5.5. that shifted it over to up 1, okay? I go to 1, 3.1, 1, 2, 3.1. I go to 2, 2, boom. I go to 3, 1.5. And I go to 4, 1.22. And now I've shifted this. Now, let's talk domain and range. What is my domain of this graph? All real numbers. What's my range?
Y
is
Greater than
1.
1. Y is greater than 1. Beautiful. Okay? It's the same thing we've been doing. I want to see your shifts. Don't forget to show me the original graph and then show me the shifts, okay? Easy?
Wait,
Yes.
if it went, I know I asked it before.
No,
but,
ask me.
When does the range become like less than?
If it's flipped down,
Oh, okay.
okay? If I have that negative out in front of this E, okay? Does that make sense? Okay. So let's look here. Let's graph this next one. I threw another one in here because the book only gives us one example. I think it's more important that we do a couple of these.
It always gives you the easy ones too.
Right here, yeah, this one's a little bit different because it has a negative up with that X too, right? So it's gonna help us a little bit. If I have a negative with the X, is my graph going this way or this way? Yep, same as here, right? Because I have a negative up here, okay? Now, what do we start with? We just simply plug in some points. -2, -1, 0, 1, 2. I'm trying to make it simple enough for you. So we're gonna plug in to focus on this. So I have 0.5, and then I have times E to the what is, ooh, look at this. Negative X and -2 gives me a positive 2. So I have 0.5 E squared. You get 3.7. Then I have 0.5 E to the positive first, right? So I get 1.4. Anything to the 0 power is, but I have 1 times a half, so I get good. Then I have 0.5 E to the -1 now, right? Because when I plug that 1 in with that negative, I get a -1. So you get 0.18. And then I have 0.5 E to the -2 now, yes? And I get 0.07. Now, I graph these points, yes? We go to -2, we go to 3.7. 3.7 is about there. We go to -1, we go to 1.4, which is about here. We go to 0.5. We go to 1.18 and right here at 2.07, yes?
Yes.
Is it following the right way?
Yes.
Now what do I need to do?
Add
I need to add 1
Why?
just to the y. Do I add anything to the x?
No.
No, because there's no shift in my x, okay? No shift in my x. So -2, 4.7. -1, 2.4. 0, 1.5. 1, 1.18. And 2, 1.07. Okay. -2, 4.7, 1, 2, 3, 4.7. This point's gonna go up 1, right? To there. This point's gonna go up 1 to there. This point's gonna go up 1 to here and up 1 to here, so this graph looks like this. Domain, range,
Y is greater.
good.
So when it's minus, then it'd be y is less than
If there's a minus in front of here,
1. Okay.
yes. Okay, anytime it leads with a minus, because it's flipping it over that y-axis or x-axis, okay? That's what. Now, let's talk about compounded continuous interest. Continuously compounded interest, okay? So we learned that if you've learned this formula already, where it has A equals P times 1 plus R over N to the NT, yeah? And that was for compound interest, yeah? This formula is for continuously compounded interest, okay? The difference between them is this. If something is compound interest, that means I gain interest off of what I put in, okay? Continuously compounded interest means I gain interest off of what I put in plus the interest off of everything else. So I'm going to gain interest off of interest off of interest off of interest, so it can build quicker, okay? Which is a good thing if you're investing in something, not a good thing if you're taking out student loans. Because some student loans work this way and some student loans work the other way, okay? So when you go to take out student loans, you gotta pay attention because there's like 2 different kinds. I think one is called subsidized and one's called unsubsidized, okay? And one of them, your interest doesn't start till 6 months after you graduate or quit school. The other one, the interest starts day one that you pull it out, okay? And when you're in school for 4 years and you're not really making payments on that, that can build really quickly, okay? Especially if I'm taking out what, like, some people take out all their college in loans, which is not smart. But I took out a total of 10,600 over 4 years.
Okay.
But that's because my school was originally like 28, but I got to go there for like about 5,000 with academics and with basketball. So I only took out like basically 2 years of my schooling for that money. And I was able to pay it off in a year. But some of my friends took out $28,000 every year. Okay, and then they married someone that took out $15,000 every year. And now they're paying more for their like minimum payment of their loans for 30 years than they pay for their house payment.
You got kids?
What?
You have kids?
Well, yeah, most of them do.
Dang. Oh,
Yeah.
that's tough.
So, you know, they're in some serious debt. And there's some people probably here at school that teach too,
Yeah.
that are in some serious debt still from school and stuff, okay? So be smart when you go to take out loans. Be smart on what college you choose. Sometimes it's not always about the college. If another college is just as equal and academic wise, but cheaper, why not choose that? Like, be smart in what you do is what I'm saying. Because you don't want to have to be paying money like crazy once you get married, right? You'd rather take like a family vacation or do something fun.
Shut up. Cool.
Okay, be smart. Okay, so if it's continuously compounded, here's the deal. You'll know when it's continuously compounded formula because it says it always in the instructions. I use that formula when it tells me to use that formula. It says you deposit $4,000 in an account that pays 6% annual interest compounded continuously. That's when I know to use that formula, okay? What's the balance after 1 year? So how do I plug this in Solve it?
You do A equals 4,000.
Mm-hmm.
E, and then your 0.06.
0.06, and what's my time?
1.
Can you solve that?
Yeah.
Yeah, because it's all calculator work. 4,000 times e to the 0.06, right? Remember when we're dealing with money? So in 1 year, you've made $247.35 off of that because it's continuously compounding. Okay, so in 1 year, you've made $247, doing nothing with that money. That's pretty simple. Now, in 1 year, if you're taking out that loan, you owe an extra $247. Yeah, that's crazy. Okay,
How does that happen?
how does that happen?
Like, in real life.
Like with credit
Because
cards?
people are just, they don't think about stuff, or they're not educated enough to like know what things are, and they don't read through things, and they just sign contracts and do
people
stuff.
use that against you.
Yeah, you gotta be smart, you know, you gotta look out for yourself at some point on some of this stuff. Okay, but listen, honestly, on your homework, you will only use that formula if it says compounded continuously. Understood? Okay, and on your quiz and test, I'll list the formulas, but I'm not gonna label which one's which. I'll list this one and that one, you gotta know which one's which, but you'll have the formula there. Can you handle that? Okay, so let's go ahead and do some homework.